Zlatý Kůň woman was a modern human who lived in Eastern Europe more than 45,000 years ago, and genetically she sits in a position that should not exist if the traditional single late migration scenario were literally true. Her genome branches off earlier than the ancestors of later Europeans and East Asians, yet she is clearly part of the Eurasian lineage of Homo sapiens. She is not ancestral to later Europeans. That means early modern humans in Europe were not one homogeneous founding group 50,000 years ago. They already represented distinct branches of a wider Eurasian population network. Her mitochondrial DNA belongs to a basal branch of haplogroup N. This is not a trivial detail. Haplogroup N is one of the founding maternal lineages of non-African humans. Almost all Eurasian mitochondrial diversity descends from haplogroup M or N. But Zlatý Kůň's haplogroup N lineage is not ancestral to the N lineages that dominate later populations. It is an early offshoot that effectively goes extinct. This demonstrates that Eurasia once held more maternal diversity than survives today. Lineages disappeared, just as Neanderthal lineages disappeared. The genetic landscape of today is the product of survival and bottlenecks, not a full reflection of ancient diversity. This extinction of lineages matters because it shows that genetic continuity is not guaranteed even within modern humans. A population can exist, occupy territory, and still leave little trace in later people. That is exactly what happened with the Zlatý Kůň population. Their disappearance from the later gene pool does not mean they were unimportant. It means later demographic events reshaped Eurasia. Now consider the Ranis individuals in Germany. Genetically, they cluster with Zlatý Kůň woman. Archaeologically, they are associated with the Linkombian, Ranisian, Yurts, Manawikian industry. These blade technologies show connections to Near Eastern industries, such as the Amarian. That linkage points toward movement through the Near East into Europe, but it also shows that early modern humans were part of a technological and cultural continuum stretching across regions. Europe was not suddenly opened at 50K. It was part of a broader network of human presence and innovation. The Neanderthal story adds another layer. Zlatý Kůň and Ranis individuals carried Neanderthal DNA, but the segments indicate the interbreeding occurred well before they lived. In contrast, individuals like OASE1 show extremely recent Neanderthal ancestry, a Neanderthal ancestor only a few generations back. This difference proves that modern human populations in Europe had different interaction histories with Neanderthals. Some groups mixed recently, others did not. This variation could reflect geography. Neanderthals were unevenly distributed across Europe and Western Asia. A modern human group moving through one corridor might encounter them frequently, while another might skirt around dense Neanderthal regions. But cultural factors may also have played a role. Human groups are not passive. They have social boundaries, mating preferences, alliances and taboos. Some groups may have intermarried more readily. Others may have avoided close contact. The genetic record captures the outcome of these behaviors. So Neanderthal ancestry does not mark a single encounter tied to a single migration. It reflects multiple episodes of interaction between populations that overlapped in time and space. Zlatý Kůň woman's lineage shows an older admixture signal without evidence of very recent contact, while OASE shows the opposite pattern. Later, Upper Paleolithic Europeans sometimes show additional Neanderthal segments, implying further local interactions. This mosaic of signals contradicts the idea of one brief meeting between two species, followed by complete replacement. The pigmentation genetics illustrate how misleading modern assumptions can be. Zlatý Kůň lacked the derived alleles that give many present-day Europeans very light skin. But those alleles evolved later, under strong regional selection pressures. Early Eurasian populations, including ancestors of East Asians, also lacked them. So absence of these variants reflects an ancestral Eurasian state. Skin color is one of the fastest evolving traits in humans and cannot be used as a simple marker of deep ancestry. In fact, she may have looked more Native American than African in the topical sense. Any reconstructions of her phenotype are gross speculation. Returning to haplogroup N, its importance lies in timing and branching. Haplogroup N represents an early diversification outside Africa, but the internal branching of haplogroup N must have occurred after populations were already distributed across parts of Eurasia. Zlatý Kůň, woman's basal haplogroup N lineage, shows that these early branches existed long enough to differentiate before some were lost. This aligns with the genome-wide evidence of deep Eurasian population structure. This shows that Europe around 40,000 years ago was home to multiple modern human groups with different histories of contact and survival. If we assemble these threads, a coherent picture emerges. By 45,000 years ago, Eurasia was already populated by multiple modern human groups with distinct genetic profiles. Some lineages, like that of Zlatý Kůň woman, branched early and later disappeared. Others, like those related to Kostenki, contributed more to later Europeans. Interactions with Neanderthals occurred in different places and times, producing varied patterns of introgression. This does not support a simplistic scenario in which a single small population left sub-Saharan Africa at 50k, mixed once with Neanderthals, and then spread like a wave, replacing all others. Instead, it supports a dynamic system of population movements, local extinctions, and cultural and biological interactions across a wide geographic range. Africa remains central to the deeper origin of Homo sapiens, but the genetic data from Zlatý Kůň and Ranis show that the story outside Africa was not a blank slate filled at one moment. It was a landscape of already differentiated populations whose histories intertwined with Neanderthals and with each other. The ancestry of living humans represents the surviving strands of this network, not the totality of ancient human diversity. Zlatý Kůň woman does not erase Africa from the human story, but she decisively ends the cartoon version in which one recent tribe marches out and becomes everyone else. She reveals instead a braided river of human populations, branching, mixing, and sometimes disappearing long before the lineages that dominate today took shape. Out of Africa used to mean something, not something in the vague academic sense. It used to mean a single clean narrative you could draw in 2 strokes. Homo sapiens evolved in Africa, and around 50 or 60,000 years ago, a small band left, expanded into Eurasia, and replaced everyone else. Full stop. That story became so dominant it wasn't just a model, it became the model, the default posture of respectable science. You didn't need to argue for it anymore. You just gestured at it like gravity. But now, if you sit with the genetics for 5 minutes, real genetics, not simplistic diagrams, one brutal truth becomes unavoidable. Nobody knows what out of Africa even means anymore. Out of Africa still gets said with confidence, like parents who tell their children fairy tales about where babies come from. It still gets invoked, like a religious creed. But the moment you ask for definitions, the moment you ask complex questions, the story collapses into a mess of incoherent explanations that contradict each other so hard they can't all be true. For a long time, the story of early modern humans outside Africa was told as a dramatic but simple tale. A small group leaves the continent around 60,000 years ago, expands rapidly across Eurasia, mixes once with Neanderthals, and becomes the ancestor of all later non-African populations. It is a clean narrative. It is also one that increasingly struggles to accommodate the growing pile of genetic, fossil, and climatic evidence. When we step back and layer those lines of evidence together, Y chromosomes, mitochondrial DNA, whole genomes, skull morphology, fossil geography, and late Pleistocene climate, a different picture comes into focus. It is not a story of one group, one wave, and one moment. It is the story of a structured human metapopulation stretched across a volatile landscape, repeatedly fragmented, filtered, and reshaped by climate shocks. The first thing to understand is that genetic trees, especially those based on the Y chromosome, do not map neatly onto population size or geographic origin. A Y chromosome tree is not a census of ancient men, it is a diagram of surviving male lines. Every generation, many men leave no sons. Over thousands of years, that process alone erases enormous amounts of Y diversity. Add social structure, dominance hierarchies, patrilineal clans, differential reproductive success, and the effect intensifies. A small subset of male lines can come to dominate even if the total population is large and regionally diverse. When we look at the Y tree and see many major branches coalescing around 50 to 70,000 years ago, what we are often seeing is not the birth of those populations, but the last common ancestors of the lines that happened to survive later filters. But that interpretation assumes that earlier diversity did not exist. Ancient DNA and fossil evidence tell us that it did. Early modern humans were already spread across parts of Southwest Asia, Europe, Siberia, and East Asia, and several of those early lineages left little or no genetic legacy in later populations. The starburst in this light looks less like an origin and more like a pruning. Mitochondrial DNA reinforces this pattern. The major non-African mitochondrial DNA lineages, M and N, and its derivative R, also show deep roots in the same broad time frame, yet their geographic distributions and branching patterns do not mirror the Y tree. That mismatch is informative. It suggests that male and female lineage histories were not identical, that populations were structured and interacting, and that sex-specific demographic processes, social systems, mobility patterns, perhaps even differential survival, shaped uniparental markers differently. Again, this is hard to reconcile with a model of a single, tightly knit founding group expanding uniformly. Whole genome data add further complexity. Some of the earliest sequenced modern human individuals outside Africa, such as those from Central Europe and Siberia around 45,000 years ago, sit on branches that are basal to later Eurasian populations. Others, like individuals from Romania or Bulgaria of similar age, show different relationships and, in some cases, extremely recent Neanderthal ancestors. These people do not line up as a neat ancestral chain. They represent parallel early Eurasian populations, some of which were absorbed, some of which were replaced, and some of which simply disappeared. Their existence shows that by the time the surviving Y and mitochondrial DNA lines were coalescing, the human landscape of Eurasia was already a patchwork. The fossils themselves echo this picture. Early modern human skulls from the Levant, Central Europe and East Asia share a broad morphological grade, large cranial vaults, relatively robust faces, and a mosaic of modern and archaic retained traits. They do not yet show the more derived regional patterns that characterize later Europeans or East Asians. This shared anatomy suggests descent from earlier modern human populations before strong regional specialization. But it does not prove direct ancestry from one site to another. Instead, it points to a wide geographic zone, from the Levant, through Anatolia, and into Europe and Asia, inhabited by related but not identical groups. Into this already structured human world, climate delivered repeated shocks. The period from about 70 to 40,000 years ago spans some of the most unstable climatic phases of the late Pleistocene. During marine isotope stage 4, global temperatures dropped and aridity expanded. Deserts grew in Arabia, forests contracted, habitats fragmented into refugia, mountain valleys, river corridors, coastal zones. Then, in early marine isotope stage 3, the climate swung wildly through abrupt warming and cooling events, known from Greenland ice cores as Dansgaard-Oeschger cycles. Ecosystems shifted on timescales of decades to centuries. For small hunter-gatherer populations, these changes were not abstract. They meant the disappearance of prey, the drying of water sources, the isolation of groups that had once been connected. When habitats fragment, populations fragment. When populations fragment, some become very small, and when small populations face further stress, cold pulses, droughts, competition, disease, some go extinct. Others survive in refugia and later expand when conditions improve. This ecological dynamic is a perfect recipe for genetic bottlenecks and lineage filtering. It can reduce diversity sharply without requiring a single origin or a single catastrophic event across the entire species. Instead, it produces a mosaic of local extinctions and survivals, played out repeatedly across regions. The genetic record fits this model remarkably well. Early lineages that show up in ancient genomes sometimes have no clear descendants in later populations. Others contribute partially, but are later overshadowed by expansions from different groups. The Y and mitochondrial DNA trees show narrow funnels in which only some branches pass through. Neanderthal admixture patterns also vary. Some early modern humans show evidence of very recent Neanderthal ancestors, while later populations carry more diluted signals from earlier admixture events. This implies multiple contact zones and repeated interactions, not a single encounter between two homogeneous populations. Neanderthals themselves were undergoing similar demographic stresses. Their genomes show signs of bottlenecks and regional isolation. Their populations contracted in some areas and may have expanded in others during milder intervals. The late Pleistocene was a time of demographic turbulence for many large mammals, and humans were no exception. In such a context, it is unsurprising that both modern human and Neanderthal lineages would show signs of pruning, replacement, and regional turnover. Seen this way, the 50 to 60,000 year window highlighted in genetic trees does not mark a moment when modern humans suddenly appeared outside Africa, or when a single group began its global conquest. It marks a period when earlier diversity had already been thinned by climatic and demographic filters, and when the lineages that would later dominate happened to pass through the sieve. Those lineages then expanded during more favorable intervals, repopulating regions where other groups had disappeared or been absorbed. The concept that best captures this pattern is that of a metapopulation, a network of partially connected groups, each with its own local dynamics, but linked by occasional gene flow. In a metapopulation, local extinctions and recolonizations are normal. Diversity is not evenly distributed. Some regions act as refugia during harsh phases and as sources during expansions. Others are demographic sinks. This framework allows for both structure and connectivity, for both shared ancestry and regional differentiation. It fits the genetic, fossil and climatic data far better than a model of a single uniform founding tribe. The illusion of a single origin event arises largely from the nature of the data we often focus on. Uniparental markers are powerful but limited. They compress complex demographic histories into narrow lines of descent. Whole genomes and the fossil record, when considered together, reveal the missing dimensions, the parallel populations, the dead ends, the episodes of mixture and replacement. Climate provides the mechanism that ties these patterns together, turning abstract, coalescent dates into the demographic echoes of real ecological crises. In the end, the early history of modern humans in Eurasia looks less like a straight arrow and more like a braided river. Channels split, merge, dry up and reappear. Some streams carry most of the flow for a time, then fade. Others persist quietly in the background. The river as a whole moves forward, but its path is anything but simple. Recognizing this complexity does not diminish the significance of expansions around 50 to 60,000 years ago. It reframes them as part of a longer, more intricate process, one shaped not by a single founding moment, but by repeated episodes of fragmentation, survival and renewal in a restless Pleistocene world. Thank you for watching.